Let's take a look at some of the problems that were assigned to you to balance, starting with number 47. The reaction between ammonia and sulfuric acid to produce ammonium sulfate. First step is to make sure that we have the correct formulas. Ammonia is NH3 and reacts with sulfuric acid. You need to know the formula of sulfuric acid. It's H2SO4. And this produces ammonium sulfate. And review how to write these ionic formulas. And there's the correct formula of ammonium sulfate. This is a perfect opportunity to take a look at some of these polyatomic ions and count them together as a group. For example, we're going to take sulfate and we're going to count that as a group because it remains intact on both sides of the equation. So let's start counting. On this side, on the reactant side, we can see that there's one nitrogen, while on this side, we can see that there are two. On this side of the reaction, there are a total of 5 hydrogen formula units, while on this side, there are 8. On this side of the reaction, since we are considering sulfate as a group, we count that as 1 unit of sulfate. And on this side, also 1. Try to decide where to begin. You can probably think about putting a coefficient of 2 right in front of the ammonia, because that causes the ammonia formula units to go up to 2, and that element is all set. And if you count the number of hydrogen, there are a total of 6 from here, plus 2 more. That's a total of 8. And just putting that one coefficient allows you to balance all of the formula units. And so the final answer is that 2 moles of ammonia react with 1 mole of sulfuric acid, and that produces ammonium sulfate, 1 mole of ammonium sulfate. And hopefully you can notice that this is a synthesis reaction. Let's take a look at question number 48. Question 48 is the reaction between hydrochloric acid and ammonia. You ought to have memorized all of these formulas by now. Hydrochloric acid is HCl, ammonia is NH3, and this produces ammonium chloride. Now that all the formulas are correct, you can probably notice very quickly that this equation is already balanced. There's a total of 4 hydrogens on each side. There's 1 chlorine on each side of the reaction, and 1 nitrogen on each side of the reaction, which just goes to show that sometimes, if you have the correct formulas, an equation is already balanced. Hopefully you can also realize that this is also a synthesis reaction. Going on to number 49. The reaction between copper 2 sulfate and iron, which produces iron 2 sulfate and copper. Let's write down the correct formulas. Copper 2 sulfate is CuSO4. Remember, in this case, copper has a charge of positive 2, shown by the Roman numeral, and sulfate, a polyatomic ion, has a charge of negative 2, which is why the correct formula is CuSO4. Iron is Fe. Iron 2 sulfate, in this case, the iron has a charge of positive 2, and sulfate with a negative 2. The correct formula is FeSO4. And the formula of copper, Cu. You probably remember to group the sulfate and count it as 1 unit. And if you do that, you'll notice this is also already balanced. 1 copper on each side of the reaction, 1 sulfate group on each side of the reaction, and 1 iron formula unit on each side of the reaction. And this is a single displacement reaction. And it gives you a comment about the relative strength of iron versus copper. And iron has the ability to knock copper off from being bonded to sulfate. Let's take a look at question 50. It's the reaction between aluminum and hydrochloric acid to produce aluminum chloride and hydrogen. Aluminum has a formula of Al, hydrochloric acid, which you should have memorized. Aluminum chloride, aluminum has a charge of positive 3, chloride negative 1. Therefore, the correct formula is AlCl3. And hydrogen, being one of those elements that's diatomic in its free unreacted state. Let's start counting. Aluminum on this side, 1. Aluminum on this side, 1. Hydrogen on the left side, 1. Hydrogen on the right side, there are 2. Chlorine on the left side, 1. And chlorine on the left side, there are 3. You might be tempted to place a 3 right in front of the hydrochloric acid. And that will result in 3 hydrogen formula units being on this side. But then when you examine the product side of the reaction, there's no way to reconcile a number 3 with these diatomic hydrogen on this side of the reaction. Hopefully at that point you realize 3 does not particularly work for this reaction. So you might try a number that is a multiple of both 3 and 2. The correct way of doing this is instead to put a 6. And if you put a 6 here, you'll notice that there are 6 hydrogen formula units on the right side, on the left side, and 6 chloride on the left side. And that should be fairly easy to fix. If you put a 2 coefficient in front of aluminum chloride, that causes the aluminum to go up to 2, but that fixes the imbalance in the chlorine. You can easily fix the aluminum imbalance by placing a 2 in front of aluminum on the reactant side. And then how do you fix the imbalance in the hydrogen? Very simply, putting a 3 next to the diatomic hydrogen. And so I'm going to rewrite the final answer. 2 moles of aluminum react with 6 moles of hydrochloric acid, and this produces 2 moles of aluminum chloride and 3 moles of diatomic hydrogen. It's pretty obvious here that this is a single displacement reaction. And this reaction gives a comment about the relative strength of aluminum versus hydrogen, because aluminum has the ability of knocking off the hydrogen from the hydrogen chloride or the hydrochloric acid. Let's take a look at question 51. Question 51 is the reaction between carbon and oxygen. Carbon, C, oxygen, another one of those elements that's diatomic, producing carbon dioxide. Don't have to look far to notice that this is already balanced. And the type of reaction, this is a synthesis reaction. Question number 52 asks us to take a look at calcium bicarbonate and calcium hydroxide.